Okay, so the first thing you can do when you try to find an inverse is switch the x and the y. Oh, here, and before I do that, look, f of x, you could think of that as your y variable in a regular old equation. Okay, so this is my y variable. I'm going to switch the x and the y variable. I'm going to put x over here and a y over here. And then my goal is to get y by itself. Once I've done that, I've got my inverse. So I want to subtract 12 from both sides. So this is now x minus 12, because those can't combine. This 12 is gone. We're left with the square root of 3y minus 3. Okay, and then we're trying to get y by itself. So right now it's being square rooted. So if I square both sides, that will get rid of the square root symbol. Because this is a power of 2, and this is a power of 1/2. When you square root something, it's a 1/2 power. Okay, so I'm going to leave this as x minus 12 squared. I'm not going to say it's x squared minus 12 squared because there's no distributed power of exponents. It can't do that. Getting closer, so I'm going to add 3 to both sides. We've got x minus 12 squared plus 3 equals 3y. And then the last step is to divide 3 from both sides. So you could write this like this: x minus 12 squared over 3 plus 1. Okay, because look, it's 3. If you break this up in two separate fractions, you could say this is x minus 12 squared over 3, and this is plus 3 over 3. 3 over 3 makes 1 here. Or you could have written it like this. This is the same thing. Either way. I'm not sure which one's easier to type out in Mobius, but here's what I would do if I was typing this. I always start, when I have a fraction, I start with my numerator and my denominator with parentheses. In the numerator, I've got to have another set of parentheses, x minus 12, that's being squared. And then still in the numerator, I've got a plus 3, and I'm dividing the whole thing by 3. So that would be a correct answer marked in Newton.